Hi guys, in this video we will be learning about exponential and logarithmic equations. We will be studying two different techniques here. So the first technique is write everything we see in terms of one fixed base. So expressing each side with the same base will help us to solve the equation. If we have the same base in both sides, then we just have to set exponents equal to each other and we will find our answer. This is the first technique. The second technique that we're going to use is taking the logarithm of both sides. So by doing so, we will equalize the numbers written, the expressions written right beside logs equal to each other. So let's start solving the questions. The first question, we have exponents in both sides of the equation. So the first thing we need to do is try to get the same base. So express each side with the same base. Can I write 8 in terms of 2? Yes, I can. 8 is equivalent to 2 cubed. So just write 2 cubed for 8. So 2 cubed raised to power x equals 2 to the power of x plus 6. So remember, if there is an exponent raised to another exponent, we multiply those two exponents. So 2 raised to power 3 by x, 3x equals 2 raised to power x plus 6. So now, um, since the bases on either side of the equation are same, then the only way these can be equal is if the exponents are equal to each other. So exponent on the left is 3x, exponent on the right is x plus 6. When I set them equal to each other, I will solve my equation. Bring x to the other side, it makes 2x. 2x is equal to 6. Dividing both sides by 2, x becomes 3. So that's my answer. It's pretty simple. What about part B? In this question, can I write 200 in terms of 5? Let's check. You can use your calculators, try and see if 200 is a power of 5. 5 to the first is 5. 5 squared is 25. 5 cubed is 125. 5 to the 4 is 625. So I don't get 200. I can't write 200 in terms of 5. So the first property doesn't work here. I'm going to apply the second property. The second property says take logarithm of both sides. So write this as log 5 to the power of x minus 2 equals log of 200. So since I am not writing any base here, which means I am using a common logarithm here, the invisible base is 10. Let's remember section 4. We have a power here in the logarithm. Then we can bring this power down in front. So exponent can be brought out in front, which becomes a coefficient. So x minus 2, this is a quantity that I have to multiply by log 5. So I need to use parentheses. X minus 2 times log 5 equals log 200. I need x alone, so divide both sides by log 5. Divide both sides by log 5. So x minus 2 equals log 200 divided by log 5. Here in this case, we can use our calculators. Everyone has this calculator in the bottom, log base 10 of something. So just type this, log 200, and type log 5 too, and see what the answer is. Okay, by calculator, we will find log 200 over log 5 is approximately 3.2. When I move 2 to the other side, x becomes approximately 5.2. So that's my answer. So exponent don't doesn't have to be an integer number. It can be every kind of number. It's our answer. So by using the log, we undo the complexity of exponents. That is the first way. We have another way for the other kind of calculators. You can just convert it to logarithm. Write this as 5 to the power of, sorry, log base 5 of 100 equals 5 minus 2. So since you have that button in the other calculators, you can directly calculate log base 5 of 200, find the answer, and isolate x. You get the same result. So that was the first part of the section, solving exponential equations.